Alright, you made it. Last section of chapter 4 that we're going to cover. This is 10.4. It's called Disjoint and Overlapping Events. Now, you may be able to think about these pretty easily. Overlapping events means that two things can happen, but, okay, so let's say it's raining and cloudy. It's possible that it's raining. It's possible that it's cloudy and not raining, but it's also possible that it's cloudy and it's raining, right? Like if it's raining, it's probably cloudy as well. So, that's something to kind of think about, okay? So, when we think about these things, we really have to think of the different possibilities of something that can happen, okay? So, we first are going to start dealing with something called compound events, and obviously compound events means that there's more than one thing happening, right? So, you might be able to hear my kid crying. It sounds like she just fell down downstairs. Probably shouldn't be laughing at my kid crying, but it's kind of funny. Alright, the first one is called the union of A and B. And the way that we really write this is we say A union B, or you can say A or B. I think the book uses or. Last year's book used the union symbol. This year's book I think uses the or symbol. What this basically means, what's the probability that one or the other thing happens? Or both. So what this is really saying is that one thing happens or the other thing happens or both things happen, right? And so what this really means is this is the probability of A and this is the probability of B, and this is the option where some things can overlap. So this is where A happens and this is where B happens, right? So what I'm really looking at here is this is the probability of A, right? The probability of A is just all of this stuff right here. That's the probability of A, right? And actually, really, this is like the universe where this box on the outside, this is the universe where nothing happens. Where no A, no B, no nothing happen at all. Okay? So, how do I change the color on this thing? Oh, there we go. Oh, okay, there. Alright. So, the boxes where nothing happens, like raining and sunny, or it's just snowing, right? It's nothing happened. So that's the probability of A, and this right here is the probability of B. But you're going to notice a couple things happen right there. You're going to notice that when I shaded that in, this part in the middle got shaded twice. So if I want to figure out the probability of A or B happening, that's basically like me saying, okay, I want to take the probability of A, and I want to take the probability of B. But what we just did was we counted that space in the middle 2 times, right? This thing right here has been counted twice. It was counted with the probability of A, and it was counted with the probability of B, so we're actually double counting something. So what we have to do is we actually have to take away the probability that they both happen. So this is the probability of A and B. So we have to take that probability away as well. Okay? Now that's going to lead us on to the next thing. The next thing is called intersection. And that's exactly what you think it's going to be. The intersection of A and B is given by this symbol, A and B, or you can write A and B. Now what this looks like is same thing. It's your A and your B, and then this is the entire universe where it lives. The intersection is specifically talking about this little spot in the middle right here. Okay? So that's specifically talking about that. Now that we might have to kind of figure out. We might actually have to figure that thing out. Okay? So there are going to be times when you have to figure that thing out for yourself. Which means that we'll actually end up going through a couple of examples so that you can see how that works. Okay? Now the very last thing is when they're disjoint. Now when they're disjoint, that means they have no common point. There's no commonalities. Alright? So there are absolutely no commonalities. Like let's say that I want to flip a coin and roll a die. There is no commonality there, right? There is going to be no overlap. So what that really looks like is here's an event and here's an event. This is A, this is B. They are not overlapping at all because there's no common ground. So if I want to find the probability that A happens or B happens, I'm going to write it as or because I think your book does that. Probability of A or B, this is really saying just, well, it's the probability of A plus the probability of B, and there's no overlap at all, right? So we could subtract the overlap, but there isn't any. So it's just going to be the probability of A plus the probability of B. This is like the best case scenario because you don't have to do any extra work. It's just the easiest part of it because all you're going to do is you're just really, adding the two things together and you're all done. Okay? So let's go through some examples. We'll determine whether this is compound, whatever it is. Okay? So let's say a card is randomly selected from a deck. Okay? So a card is randomly selected from a deck. So what we're basically saying is, if a card is randomly selected, now I'm going to ask you a couple things. A card is randomly selected from a 52 card deck. You have an equal chance of picking all of them. What's the probability that it's red? So if we're looking at the probability that it's red, okay, let's say red. There's 26 red cards, so 26 out of 52 means that we have a 1 out of 2 chance of drawing a red card. You probably knew that, right? So let's say, what's the probability that card's a king? So new question. So this is question 1, this is question 2. What's the probability that card's a king? Well, it's 4 over 52, right? Which is the same thing as 1 out of 13. I have a 1 out of 13 chance of grabbing a king. I don't care what the king looks like. But now let's make it a little bit more challenging, because now we look at this. What's the probability that it's red and a king? Basically, the question is that I'm asking you now, how many red kings are in the deck? Well, there's the king of diamonds, and there's the king of hearts. So there's 2. So 2 out of 52, which means I have a 1 out of 26 chance of grabbing this thing. Okay? Now the question is, this is where things get a little bit confusing, and we have to decide whether there are any overlaps. What's the probability that it's red, or it's a king? I'm drawing one card. What's the probability that it's red, or the probability that it's a king? So now we have to figure out, is there any overlap? The question is, are there red kings? So are there red kings? And the answer is obviously yes, right? So when we do this, we're going to say, okay, the probability that it's red is 52, plus the probability that it's a king is 4 over 52. But right now, if you think about this, think how I've double counted this. Right here, I'm counting the king of diamonds, and I'm counting the king of hearts right here, because those are both red cards, right? And right here, I'm counting the king of diamonds, and I'm counting the king of hearts, because they're both kings, right? So in this example, I've counted the kings, and in this example, I've counted the kings, so I've double counted them. So since I've double counted them, that's really saying there's 4 cards when there aren't, right? Because if I counted the 26, or if I counted the 2 red cards here, then I shouldn't be counting them here, or vice versa. So what I'm going to do is I'm going to subtract however many red kings are in the deck, which is 2 out of 52, and that will leave me with my final answer, and my final answer is going to be 28 out of 52. So basically, if you think about that, there's 2 black kings, right? So there's 26 red cards and 2 black kings, so 26 plus 2 is 28. That gives me my 52 total. Okay? So when we think about those cards have been counted twice. Now let's look at it a different way. Let's say that we want to know the probability of choosing a jack or a queen or a king. So now we have to figure out if there's any overlap. Are there any jacks that are queens? Are there any queens that are kings? Are there any jacks that are kings? And the answer to those is all no. Because a jack is a jack, a queen is a queen, and a king is a king. So if I look at this, this is no overlap, which just means that I can add all these together. 4 out of 52 plus 4 out of 52 plus 4 out of 52 equals 12 out of 52. And that simplifies down. Oh, I did math bad on my notes, so I got to fix that. I'll do that right now. I'm thinking about it. So this simplifies down very nicely to 3 over 13. So I have a 3 out of 13 chance at grabbing a jack, a queen, or a king. So that's what that looks like. Okay? So let's go through a couple more examples, because we've still got a little bit of time. So now let's go through a couple more examples that might make things a little bit challenging. Okay? So what I want to do is let's kind of think and go through a couple of the processes and see what actually happens. So I'm just going to read this part. So I need you to, and I'm going to kind of abbreviate my question as I'm reading it, but I need you to think about this. Okay? So 3 cards are randomly selected from a standard deck. You're going to hold all 3 of those cards in your hand. You're going to take 1 card, hold it, take another card, hold it, and take another card, hold it. You will have 3 cards at the end. Okay? Now I want to know what's the probability that they're all spades. I want to know what's the probability that they're all spades. Okay? So we start out by saying, okay, what's the probability that they're all spades? Well, there's a 13 out of 52 chance the first one is. There's a 12 out of 51 chance the second one is, because I've taken one out of the deck and now I'm holding the other one. Now there's an 11 out of 50 chance of the third one. When you multiply all that together, you get a 1.3% chance. That's why flushes are so rare in poker, right? So that's what you have to think about. That's a pretty straightforward question, because there's really no or question, right? I want it to be a spade and a spade and a spade. And if I want it to be a spade and a spade and a spade, then I'm just going to go through this process. Now I'm going to leave this up there so you can see what this kind of looks like. Now, what's the probability that they are all face cards or hearts? So you want to think about this as face cards or hearts. So you want a face card or you want a heart. Okay? Now we're only talking jacks, queens, and kings for face card. Okay? So what's the probability that it's a jack or a face card or a heart? And now we're also going to change this, and we're going to say that they're replaced. So I'm going to replace all of these cards. I'm going to take one and put it back, take one, put it back, take one, put it back, take one, put it back. Okay? So now what you're really thinking about with this is I have to figure out this part before I can figure out this part. So what I'm going to do is I'm going to say, okay, how many face cards are there? Well, there's 12, right? And then I'm going to say, okay, how many hearts are there? Because I either want it to be a face card or a heart. If it's a face card, I win. If it's a heart, I win. The end. So I want to figure out how many hearts there are. There's 52, or there's 13. But now I have to think, are there any face cards that are also hearts? So you think about that. You think about the jack, queen, and king. Are there a jack, a queen, and a king of hearts? Well, obviously, yeah, there are, right? So there's 3 face cards that are also hearts, and I've counted them here, and I've counted them here, which means that I can't count them twice, I have to count them once. So I get 12 plus 23 is 25, minus 3 is 22, so that's basically saying that I have a 22 out of 52 chance of winning with 1 card. But now it wants me to choose 3 cards, right? At the very beginning I said 3 cards are selected, and now we're putting them back into the deck. So it's going to be 22 out of 52, that gives me 1, and I need to know my chance at the next one, 22 out of 52, and my chance at the next one, which is 22 out of 52. And when you multiply all that stuff together, you get 7.6%. And obviously your percentage should be a little bit higher because there's more cards to win, right? There's 22 cards that make you win versus the 13 cards that make you win at the very beginning. Also, it gives you a little bit more because you're replacing those cards as things go on. Okay? So, we're approaching 15 minutes, which is what I try to keep all my videos to. If you have questions on this can get kind of challenging. Okay? If you have questions on this, ask me about them. Say something. Say, hey, I don't understand. Could you actually show me? And then maybe I'll try to, find a different way. It is super helpful when you're dealing with card questions to literally get a deck of cards out, hold the deck of cards in your hand, and separate it into what you want. So if you look at this, if you want to see how many cards there are that are face cards and hearts, or hearts, take them out of the deck. Take all 12 face cards out of the deck, take all the hearts out of the deck, and count how many you have. You will have 22. Okay? That's going to be a super helpful tool for all of you if you struggle with this. Now, if you have questions, please let me know. Talk to me. See what's going on. You're going to have a performance task at the very end of this chapter. So if you've been keeping up, you're going to have a performance task up next after the little brief one-question quiz that follows this section. So just make sure that you ask. Make sure that you see what's going on. Make sure that you have some sort of understanding before you work on that performance task. Okay? Let me know if you have any questions. Until next time.